Hello everyone. Today I would like to show you what is the Laplace transform for non-continuous function. Okay, for non-continuous function, one of them is the unit step function. So unit step function. So this is an example. What is unit step function? Okay, for example, unit step function we name it as a ut, and then ut is from 0 to infinity, so it's the unit step function with the x-axis is t. Okay, now let's look at the example. Okay, by applying the definition of a Laplace transform, find the Laplace transform of the step function as shown in this figure. So this one is a ft, and then you have this kind of function. Okay, so how do you use the definition of Laplace transform to find this Laplace transform? So first of all, you need to know what is the ft is. Okay, ft. Okay, first of all, what is this y is the okay, here is 3 and here is 6. So this line, the gradient is 2. So it's a x-axis t, so it's a 2t. Okay, so ft is equal to 2t from 0, okay, from 0 to 3, from 0 to 3, and then after that is a -1 for more than 3. So -1 for t more than 3. That's the ft. Okay, then by using definitions, so we know that Laplace transform of the ft, then we use the formula. As we learned before, the formula of the Laplace transform is 0 to infinity, exponent -st ft dt. So the ft here is 0 to t, right? So we substitute the value 0 to 3, exponent -st, then ft is 2t dt plus, and then 3 to infinity because t more than 3, so doesn't mention up to where, so it should be up to infinity. So t to infinity, exponent -st, and then the ft is -1. So we can solve it. Do the integration. So you have exponent st and 2t. So we can use the tabular method. We can use the tabular method. Differentiation and integration. So I assume the differentiation is 2t, and then integration is exponent -st. So differentiate 2t, you will obtain 2, and differentiate 2, you will obtain 0. And integrate the exponent st, you may obtain exponent -st over -s. And then as integrate again this exponent -st over -s, that would be exponent -st over s squared. So as you know, the tabular method, you have the positive and the negative here. So at the end, we will obtain 2t, this one, 2t times with the exponent -st over -s. So 2t exponent -st over -s, and then minus with 2 exponent -st over s squared. So this one will be 0 to 3. Okay. And then you minus because -1, so minus with 3 to infinity exponent negative st dt. Okay, this will equal to, you substitute the t with 3 and then substitute with t with 0. So you will have, when substitute t equal to 3, so you have 6 exponent negative 3s over negative s minus 2 exponent negative 3s over s squared, then minus 0 minus 2 over s squared, then minus exponent negative st over negative s. This is 3 to infinity. Okay, when you solve it, you may obtain negative 6 over s exponent negative 3s minus 2 over s squared exponent negative 3s plus 2 over s squared minus exponent minus infinity over negative s plus exponent negative 3s over s. Okay, and this will equal to, so this one will equal 0, negative 6, negative 1, so you have negative 7 over s exponent negative 3s minus 2 over s squared exponent negative 3s plus 2 over s squared. Okay, so this is solve the Laplace transform using the formula of the Laplace transform. But for the unit step function, you have to know how the graph looks like. In order to plot the unit step function, you need to know how the graph looks like for the shifting and non-shifting graph. Okay, for example number 2. Let's say if you have a graph like f1t equal to t, if the f1t equal to t, how's the graph looks like? Okay, as you know, if you plot the f1t is equal to t, it should be like this. Okay, for example, this is 2, this is 2, so this is a line, the gradient is 1. Okay, but what if you have the graph like f to t equal to t and then multiply with ut minus 2? Okay, in order to plot this graph, some of the unit step function that you need to know. Okay, for example, as I showed you just now, ut is from 0 to infinity. Okay, what about ut minus 2? If ut minus 2 means that t start from 2. So t start from 2 to infinity. Okay, so for ut plus 1, what is ut plus 1? If ut plus 1 means that when t plus 1 equal to 0, so t equal to negative 1. So t is from negative 1 to infinity. Okay, what about u negative t? If ut is 0 to infinity, so if u negative t means that is from 0 to negative infinity. Okay, so it starts from 0 to infinity, 0 to negative infinity. So this one is 2 to infinity, and then this one is negative 1 to infinity. Then what about u negative t negative 1? If negative t, negative 1, what does it mean? If t negative 1, if ut minus 1, if ut minus 1, let's say is ut minus 1, it starts from 1 to infinity. 1 to infinity. So if u negative t negative 1 means that is the folding version. It's a folding version of ut minus 1. Initially it's from here. Now it goes to behind because it's a negative t. So what I can say here, u negative t negative 1 is from 1 to negative infinity. Okay, I believe that after this few example, you know how's the graph of the ut minus 2, or ut plus 1, or u negative t, or even u negative t negative 1. So now let's back to the question. Tut minus 2 means that if t is the graph like this, you have the t like this, and then ut minus 2. Ut minus 2 means that it starts from 2 to infinity. So the graph would be like this. So you will chop up the front part, you will just left 2 to infinity. Okay. Now the third example. If t minus 2, ut minus 2. If t minus 2, okay, and ut minus 2, ut minus 2 is chop off the front part. But if you multiply with t minus 2, t minus 2 is a line. It's a line of t minus 2 intersect at the negative 2, at y equal to negative 2. So t minus 2 multiplied with ut minus 2 means that both shift everything to the right 2 unit. So this will be, you shift initially ft, okay, ft is at this, so you shift everything 2 unit to the right. So that will be, start from here, 2 unit to the right. So this is shift everything to the right. Two unit. Now look at another example, which is exponential graph. For example, g1t equal to exponent negative 2t. So how's the graph looks like for the exponent negative 2t? Okay, so is exponential. This is maximum is 1, decay nearly to 0. So this is exponent negative 2t. This is 1. Okay. Okay. Now, what is the graph for exponent negative 2t ut minus 2? If ut minus 2 means that the graph, you will chop up the front part and start from t equal to 2, right? Okay, now, so let's say this is 1, this is 2 here. Okay, for exponent negative 2t, okay, you have the graph like in the question 1, and then you chop off the front part. You just left the graph will start after 2. So I draw in a different color. So this is 1, this is 2. So based on the question 1, you have this line, this curve for the exponential 2t. But if you chop off the front part, you start from the t equal to 2, you will just have this part only. Yeah. So this is the first part. This is the exponential negative 2t multiplied with ut minus 2. Okay. Now let's look at the third example. If you have a graph like exponent negative 2, t minus 2, and then ut minus 2. Again, is quite similar from this one, in which it shift everything to the right, right? T minus 2 is shift everything to the right 2 unit. So similarly to this graph, you shift the graph of this first one 2 unit to the right hand side. 1, 2. So this is 1. So the maximum is 1 here. Okay, I draw it in the blue color line. Okay. So this is the graph for the exponent negative 2 in the bracket t minus 2 ut minus 2 means that you shift everything to the right 2 units. Okay, hope you can understand what is the unit step function, for what is a unit step function for shifting, and the combination of the graph ft with the ut. Okay, thank you for watching.